So degrees, we always write 180 degrees, 60 degrees. Radians will have no units after the number. In order to, really what radians are, we're comparing, radians compare arc length, how far around a circle, to the length of the radius. So radians, we're comparing arc length to radius. And that comparison, one radian is an angle created when the radius is equal to the length of the arc length. So what that means, if we have a circle of some radius, it doesn't matter what the radius is, so that's our radius r, the arc length, so the distance around the circle we're going to go, is also going to be r, and that angle here would be, get a different color, that angle is 1 radian. So the question is, how many radians do we have in a circle? And so if we actually draw it out, if this was a perfect all to scale, and we did 6 of these angles, 1, 2, 3, 4, 5, 6 angles of 1 radian, we would end up 1, 2, 3, 4, 5, almost completing a full rotation. So we just have that little bit that's going to be left over. So it's 6 and a bit radians are in one circle. And we can actually calculate this a little more exact, quite a bit more exact. So this angle here that we were looking at, we were comparing arc length to the radius. So the ratio of the arc length to the radius, that's what we're looking at in radians. If we look at a full circle, the arc length of an entire circle, that's the circumference of the circle. When we go around a circle, a full rotation, we're really just looking at the circumference, and the radius of a circle stays the same. The radius of a circle has a consistent radius all the way around, and so circumference is always 2 times pi times r, and r is our radius. And those r's are going to cancel out, so that means the angle for one full circle is 2 pi. 2 pi, if we look at our calculator, 2 times about 3.14 gives us about 6.28. Oh, and that's 6 and a bit from up here. So that 0.28 is the extra bit that we didn't quite know. So a whole circle, a whole revolution around a circle is either in degrees, 360 degrees, or 2 pi in radians. So 360 degrees and 2 pi are the exact same thing. So we'll look at kind of an example of how we actually calculate, or can calculate, based on different information we might have. Excuse my drawing of a circle here. It's a little better. So we're going to look at two angles. We'll call it theta A, theta B. And we'll have a radius of 2.4 centimeters. This arc length from point A to point B will be 3.7 centimeters. And this will be 0.9 centimeters. So we'll look at our first angle to point B. And so, as we sort of mentioned before, these angles in radians, they're always going to be the arc length over the radius. So our arc length is going to be 0.9 centimeters. Our radius is 2.4 centimeters. And because we're dividing two lengths, we have the length of our arc length, the length of our radius, is the same units, centimeters over centimeters. Those units cancel out, and then we just need to see 0.9 divided by 2.4 gives us 0.375, or about 0.4 radians. So we mentioned this before, radians are unitless. The units will cancel out because we're looking at a length divided by a length always. Generally, we'll either write nothing, or if we want to distinguish from degrees, you might write radians just to let people know that we're working in radians. But that's not written there as a unit. This means the same thing. We don't need that unit here. Whereas when we're talking about length, we need to talk about centimeters or meters or feet. We need that measurement for it to make sense. We'll also look at angle A, theta A. So again, our arc length, or A, over our radius, R. Our arc length is 3.7 centimeters. Our radius is 2.4 centimeters. Again, our units are going to cancel out. 3.7 divided by 2.4, we get approximately 1.5 radians. So here our arc length was less than our radius. Here our arc length is greater than our radius. So this measurement here, because our arc length is bigger than the radius, it's going to be more than 1 radian. 1 radian was when they were exactly equal to each other. We don't necessarily need these drawings. We could be told these measurements without the drawing and easily calculated as well. So there's a couple examples here. They give us a radius of 25 centimeters and an arc length of 30 centimeters. So then our angle in radians, we're doing arc length over radius, which is 30 centimeters divided by 25 centimeters, which will be 1.2 or 1.2 radians. Again, we don't need to write radians because that's not a unit of measurement. B, they tell us R is 25 centimeters and arc length is 0.5 meters. We're going to do the same thing. Arc length over radius, but the problem is here we don't have the same units. We have centimeters and we have meters. So we need to convert one to the other. In the example, they convert to centimeters. You can also convert this to meters. So our radius would be 0.25 meters. We divide by 100 because there's 100 centimeters in a meter. And if we do it that way, we have 0.5 divided by 0.25, which gives us 2 radians, or 2, which gives us the exact same thing as the other example. So it doesn't matter which one you convert, you just need the same units. C. Now our angle is 3 radians, or 3. Our radius is 2.4 meters, which means we don't know what arc length is. So we're going to set up our equation. Theta equals A over R. And now we know theta has to be 3. Our radius has to be 2.4. We don't know what A is. So we need to multiply both sides by 2.4. And we get A 2.4 times 3. Maybe 7.2. And because we're talking about meters, our arc length is also a length. So this has to be meters as well. Now one more example they give. D theta equals 100 degrees. And arc length is 2 centimeters. So our formula, that theta is arc length over radius, this only works if theta is in radians. That's what this calculation was, arc length over radius. That only gives us a measurement in radians. So because this angle's in degrees, we don't know what that means in terms of radians. So we only know what A is. We don't know what our radius is because that's what we need to find out. But we also don't know what theta is in radians because we don't have a conversion at this point. So we're going to go ahead and look at how can we convert between radians and degrees. So we already talked about going around one circle. We can either write it as 360 degrees or 2 pi radians. So we'll see what happens if we have 1 degree. So we're going to divide both sides by 360. 360 degrees divided by 360 is going to be 1 degree. 2 pi over 360, well, we can cancel out a 2 and a 360. We're going to get pi over 180. So 1 degree equals pi over 180. We don't need to find a decimal approximation. This is the most exact answer. So in order to convert from degrees to radians, for every degree, we have pi over 180 radians. So that means we multiply by pi over 180. Let's look at the same equation. So 360 degrees is the same as 2 pi. Now let's look what happens if we get to 1 radian. So we're going to divide 2 pi radians by 2 pi, divide by 2 pi. On our right side, we're going to get 1 radian. On our left side, 360 divided by 2 pi. Again, 360 and 2, we can divide both by 2. And we get 180 over pi. So every radian, we have 180 over pi degrees. So to convert from radians to degrees, we're going to multiply by 180 over pi. So we'll look at a couple examples. So we're going to convert to radians. First example, we have 20 degrees. And in order to go from degrees to radians, we multiply by pi over 180. We have a common factor of 20, so we can divide by 20. 180 divided by 20, we get 9. And so that's going to give us pi over 9. And so if a full circle is 2 pi, half a circle is 1 pi. We divide that pi into 9 pieces. Each of those pieces is pi over 9. Again, this is 180 degrees for half a circle. If we divide that by 9, that gives us our 20 degrees. B negative 225 degrees. Negative 225 degrees. We're going to go back 90, 180, 225. That's negative 225 degrees. So we know we're going back at least 1 radian. We're going back at least 180 degrees. So let's see what happens. We're going to multiply by pi over 180. 225 and 180. We can divide by we have a common factor of 45. So we can, you don't need to simplify it all at once, but eventually this will simplify down to 5 over 4. This is going to be negative 5 times pi divided by 4. Or negative, let's write this a little bit bigger. I don't know how well this stuff necessarily shows up on the video. So I'll do it a little bigger so you can see. But this is going to be negative 5 pi over 4. The negative 225 degrees is the same as negative 5 pi over 4 radians. On that page, C, 900 degrees. 900 degrees, we're going around a full 360 degrees, and then another 360 degrees brings us to 720. 720 plus 90, we're at 810. 810 plus 90, we're at 900. So we're going around 2.5 times. So you might be able to guess what we're going to get in radians if we're going around 2 pi radians 2.5 times. We can still use our same method we've been doing. I'm going to multiply by pi over 180. You can definitely divide these both by 10. So we get 90 over 18. Those both still have factors of 9 in them. So we can divide each by 90. Divide both by 180 actually. 900 divided by 180 gives us 5. 180 divided by 180 gives us 1. That's going to give us 5 pi. So going around one full circle is 2 pi. Another full circle is 2 pi, so we're at 4 pi. Half a circle is another pi, so that brings us to 5 pi. So we can kind of think about it and think, does our answer make sense? And now we'll try going the other way. So let's convert to degrees. So let's look at 5 pi over 3. So converting from radians to degrees, we multiply by 180 over pi. So we need to multiply by 180 divided by pi. We have a pi in the top and the bottom. 180, if we divide by 3, we get 60. Divide that by 3, we get 1. So we're left with 5 times 60 is going to be 300. And then we have just 1 in the bottom, so this is just going to be 300 degrees. So 5 pi over 3, almost 2 pi. We're just missing a third of a pi, a third of a half a circle, a third of 180. So we're missing 60 degrees. I don't know if that helps at all. That's at least how I kind of think about it. But this method of multiplying by 180 over pi or pi over 180 will always help you convert. What about 1.75 radians? So again, we're multiplying by 180 divided by pi. So 180 times 1.75 is 315 divided by pi, or divided by approximately 3.14. If we do that, 315 divided by 3.14, you can use the pi button in your calculator. It'll give you a more exact result, but this is going to be approximately 100.3. This is in degrees. So we're not always going to have radian measures that have pi in them, where the pi is going to cancel out nicely. As we saw before, we can measure things based purely on the arc length compared to the radius. So if our arc length is 1 3/4, 1.75 times the radius, we still have a radian measure. We have a nice rounded one that doesn't give us some continuous decimal. And that'll still convert into degrees. Look at one more radian measure, a nice round -3. So we're converting to degrees. We need to multiply by 180 over pi. Or 180 over approximately 3.14. If we put that in, we get negative 172 approximately. If we round up. So this nice, clean -3 in radians actually gives us negative 171.9745223. It gives us this long decimal. So things that are nice round numbers in radians are ugly decimals in degrees. Things that were nice round numbers in degrees, if we see what 5 pi is, we're going to get a nice long decimal again. And that's just because we're multiplying by something involving pi. But there are some of these more common degrees that come up over and over again. 360 degrees, 180 degrees, 90 degrees, 60 degrees, 45 degrees, and 30 degrees. And if you're having some flashbacks from grade 11 math, you'll know that some of these will be useful in this trigonometry unit, if you remember your special triangles, but we'll get to that in another lesson. But these are ones that we're going to use quite frequently. We already talked about 360 degrees is just 2 pi, one time around a circle. 360 degrees, 2 pi radians. If we do half of that, we get half the radians. 1/4 of that, or half of a pi, half of 180, we get pi over 2. $60 degrees is a third of 180. So we have a third of pi. 45 degrees is a quarter of 180. So we have a quarter pi radian. And 30 degrees, we can split 180 into 1, 2, 3, 4, 5, 6. It's a sixth of a pi. These might seem like kind of random numbers at this point. We're going to get used to these because we're going to be using these quite frequently throughout this unit. And then for any larger angles, we think of them in terms of these kind of base units in a way. So for instance, 135 degrees. Well, we can do the normal conversion. 135 degrees, to get into radians, we need to multiply by pi over 180. And if we simplify that down, we get 3 pi over 4. You need to find your common factors of 135 and 180 in order to simplify that fraction. But I know you're all capable of that. Or 135 degrees, well, that's just 345 degrees. And 45 degrees is a pi over 4. So it's just 3 pi over 4s. Or 3 pi over 4. 120 degrees. Yeah, we can do our conversion. 120 degrees times our pi over 180. 120, 180, we can simplify that down. 12 pi over 18, or 6 pi over 9, or, oh, they both divide by 3, 2 pi over 3. Might take you less steps than that, but it's a little bit of work trying to reduce that. 120 degrees, also, that's just two 60s together. Well, 60, we already know 60 is pi over 3. And this just has to be 2 pi over 3. You might find it easier to do the conversions. Maybe you really like the reducing fractions. You find you can do it very quickly. But as we get these ingrained into our head, it might be easier just thinking of these as multiples of these kind of base units that we've talked about. And this last part is not completed on the completed note. So if you've watched this part, could be beneficial. 2 pi over 3. If we want to draw this, 2 pi is one complete rotation around the circle, and we need to divide that into 3. So we need to divide one full rotation into 3 sections. So maybe something like this. And we might have approximately 3 things that are equal to each other. I know it's not quite perfect, but if we're asked, oh, what is that angle in degrees from that drawing? Well, it's just a third of 360 degrees, or 120 degrees. It's 360 divided by 3. Five pi over 4 so 5 pi over 4, that's really just pi plus pi over 4. That's going to be 180 degrees for the pi. And then pi over 4, we need to go a quarter of the way here. That's our pi over 4. So that's 180 plus a 45. That's going to be 225 degrees. Similarly for this one up here, we could have done 2 pi over 3. That's like a pi minus a pi over 3. A 180 minus a 60. And that gives us our 120. So we can break up even these more complicated ones into simpler terms that we already know. So 11 pi over 6, that's going to be a 2 pi minus a pi over 6. That's 180 degrees minus 30 degrees. Sorry, 2 pi is 360. Which would give us 330 degrees. This 11 pi over 6 we go around 11 all the way to here, that's the same as 330 degrees. There's two more in here that are even, they are just these base radian measures that we've been talking about, so I'm going to leave them, but that's kind of your introduction to radian measures. And if you have any questions, if you're finding this change from degrees to radians difficult or weird, let me know. I can try to go over things a little more. But for now, I'm gonna sign off, and I hope all is well with you guys. And you'll hear from me again soon. Bye.